So next up, we want to be fair in our treatment for bridge types. Yesterday we heard from Ozzie Bayrak about the Concrete Bridge Engineering Institute. So we wanted to give fair time to the steel folks. So we have Rob Connor, who's going to talk to us about the SBRITE at Purdue University. So
my name's Rob Connor. Somebody asked me this morning if I teach. I try to. Professor at Purdue University. Nice to see a lot of familiar faces down here and be back in person with these kind of conferences. I'm the director, though, of our SBRITE Center at the university. I always have to have acronyms for things, right, to get anybody's attention. And so our acronym is SBRITE. It's not that we don't know how to spell the word bright at Purdue, but it's an acronym. And although we're Boilermakers, kind of viewed as not so bright sometimes. But anyway, our focus is on the aging steel bridge infrastructure, but really anything related to steel. So what are we? It's a center focused on, basically helping folks like you maintain your existing steel bridge inventory, right? People get old, they move on, they change careers, your budgets are cut, and all that legacy experience. At the universities, we're not teaching a lot about old stuff so much. We have the luxury of Purdue, we can do some of that. But you're still stuck with those structures. And in fact, what I kind of heard today from everybody is that's where all your risk is, right? That's what I always tell folks. It's the bridge on paper you haven't designed, there's no risk yet. It's the stuff that's built, right? That's where all the risk is going to be. And so how do you deal with those structures? And so what do we do? Well, a lot of what people like, who are our partners, and I'll talk a little bit about that, is the training, the hands-on training that we offer at the center, specifically on inspection or maintenance and repair. We have another acronym called the DEN. The DEN is the room where all the books are and the smoking jackets back in the day, right? All the experience hangs out in the DEN. Well, that's our distributed expertise network, right? A lot of owners don't have the welding expert anymore. But we can get a hold of somebody, right? Or we have somebody we can contact through the center to provide unbiased support for our partner states. And then, of course, research, and I'll talk a little bit about that. How are we funded? We are a TPF, a pooled fund study. It's actually in phase 2 because our first one went on long enough when we were told we had to close that one out. So we're sunsetting 281 and 486 is the new one. We've had excellent support around the country, as you can see there. And so in one way or another, the states are, hopefully I didn't miss anybody, are providing support through the pooled fund study. There's different avenues that people provide support through, either special studies, like North Carolina, for example, is doing, and then there are our traditional partner states like Texas. Stephen's a supporter of that, where they get different benefits and so forth. And then Federal Highway has just recently kind of rejoined. Some states are in, then they come out, they get training, they'll go back and forth. But always looking for more folks. And that's kind of what today is to talk about. So we were initiated as TPF 281. It was official, I think, in 2013, if you look at the pooled fund site with the solicitation in 2011, 2012, around that time frame through Indiana. And INDOT led the effort in terms of some development work that I'll show you, as well as Purdue saw the value in a center like this, a national center that didn't really exist or doesn't exist to this day. Here's the big one. 22 acres were provided through the land grant part of Purdue University, the original land grant land, dedicated to aging infrastructure, with the Steel Bridge Center being the largest user by far. And so what is that? Well, it kind of started with this idea that, you come to presentations, I do these things, right? It's all PowerPoint, and we teach you this, and we're falling asleep. And the thought was, well, rather than show you a picture of some crack, wouldn't it be cool if we could keep that cracked member or a corroded component or an impacted girder? But you need property for that. And that was the big idea, which then kind of took off within Purdue, honestly, and with INDOT. And so then it turned into, well, we found some property, about, like I said, 22 acres. The top half above that green line there's some high voltage lines that run through our property. That's what's been developed, about half of it. And the idea is keep some of these components. And so there's the green space before we put some bulldozers to the ground, started erecting some components on our own, which then turned into a full construction project to have a facility. And so what I'm going to have to do, I'm going to be one of those people who unfortunately has to do this, is jump out of my PowerPoint to play a video that I'm going to try to narrate for you just to give you a feel for the facility. So this is, Army Corps actually shot this for us. They're one of our partners. So this would be on our west end, and so that tall frame you see off to the left, that's a probability of detection study frame, the only study of its kind done statistically significantly where there are real members with real fatigue cracks, except we know where they are, and the inspectors didn't. Brought in 30 real bridge inspectors from around the country to look at probability of detection with the goal of not saying, you know, how bad people are or how good people are. What do we need to do to improve training, right? How do you find an out-of-plane distortion crack? Well, it turns out most inspectors, or a lot, haven't seen them. Cover plate cracks, we worry about those. A lot of people haven't seen cover plate cracks. How do you find them? So what techniques help with that? Off to the right there is some construction. Other people use the facility, so our construction folks are doing some training there as we move along here. So this would be headed east. Purdue main campus and airport are off to the left if you've been Purdue. Now this is 2 years old, this video. There's already a lot of this has been used up, some of the space with other work. Off to the right there is our truss station where we have high-strength bolted trusses, which are kind of unique, right? You don't get those a lot. Old riveted members. The truss you see to the right is a 90-foot span through truss to give you some scale, full-scale truss with different types of decks on it. Different retrofits that we've introduced that are good and bad from a training perspective, right? Here's how not to do it, here's how to do it. Some heavily corroded railroad components there down to the lower right-hand side. Off to the left, you see a big green space and some towers. That's where we're hoping to get some railroad track installed and install some railroad signals. Coming up on the left are some slabs from some bridge that was taken out of service. We're using that for some non-destructive testing of decks on steel girders. And then coming up, you can imagine that's our plate girder section where we have large plate girders. For scale, the big girder there standing up is from Minnesota. It is 23 feet deep. Not a lot of plate girders that big. Flanges 3 feet wide, 3 inches thick. Various types of plate girders, pin and hanger details to show inspectors, different out-of-plane distortion damage, impact damage, and whatnot. Kind of a general laydown yard of some pieces that have arrived that haven't been erected yet. And then up here on the left is what we call everything a station, where different components are. This is our railroad station with 2 of our railroad bridges, a 40-footer and a 65-footer. The 65-footer is the long one there. You see some signals off to the left. Getting 2 more full-scale railroad bridges coming in from the TTCI Research Center out in Pueblo. It's a more laydown area with some of our sign structures that are used for inspection. Hopefully get some of that up soon. And then our on the right there is our Forensic Specimen Observation Gallery, or you may recognize it as a pole barn. But see, at the university, you have to call it fancy. And that's where we keep our equipment and whatnot, and then also specimens we don't want outside that would continue to deteriorate. Large center, a lot of opportunity for training, and that's really what sets the facility in the center apart, I think, from in terms of training overall and capability, and that's what people like. In case the video didn't work, just some zoom ins on some of the different components. And I'm going to go through these quick because our video worked today, but real components with real damage and real details and so forth. One of the ones inside the shed that always gets a lot of attention, we're the only facility that has any of the I-35W components anymore. Federal Highway as well as NTSB has provided everything back to us, and we took one of the 35 joints and re-erected it to kind of show that. Now, if you think about just that specimen, that's bridge inspectors there, I believe, in that image, but undergrad students come down for classes, right, if you're taking a steel design class, and graduate students and so forth. So it's a kind of a soup to nuts, right? As you're training people, we're trying to catch them early on. And then our big plate girders. That's former research engineer Jason Lloyd standing in our 23-foot deep plate girder, right? So again, big things with a lot of different components and damage. And just a lot of other little stuff people have provided to us. But the big part with that then is the training, right? The opportunity to go out and look at things. There's a gentleman named Phil Sauser who recently retired from the Army Corps of Engineers. Some of you may know Phil, and we were walking through there. Army Corps does all their fracture critical training at SBRITE now because of the specimens. And they've been coming to us for 3 or 4 years. They're a partner. And we were walking through, and he said, you know, what's really neat here is you can see in about, 2 hours what it would take you to see in a 20-year career, because we keep the bad stuff, right? That's what we keep from the training perspective. And so that was a big compliment that we have so much bad stuff, right? So that's what we're looking for all the time, are the things that will help us from a training perspective. And that is one of our big focuses. One of the things the challenge for the partners, right, is everybody coming to Purdue to use the facility. And for years, we would try to go out and do some of the inspection or design training and take a few specimens. But recently, we acquired an F550 truck with a trailer, partnered with the Bowen Lab, the big structures lab at Purdue. And we're able to take that class on the road pretty effectively. We did some beta testing just down in Austin, Texas. We did 2 classes where we brought a whole bunch of pieces of steel. And so we're going to be up in Michigan with that coming up in September, and it seems pretty effective to be able to take a lot of specimens with damage. One of the things I've recently learned about is that you can get your own training approved by Federal Highway to be NHI, because people are asking, well, we're taking your fracture critical. We like it better than NHI's, is what we've been told. But it's not approved, and I didn't know you could actually do that. So we're going to work to get that as an approved NSTM version of the class, which means if you took ours, then that would satisfy Federal Highway, and they're on board with supporting that, but we just have some paperwork. And then one of the other fun classes, it's the best class you'll ever hate, as one of the students said, is this idea of implementing effective retrofits. A lot of discussion here about fatigue cracks and different retrofits. We're going to be able to take that on the road too, and I'll show you a little bit more about that. I think, I was adding up some numbers last night. We're easily over 1,000 individuals who've come through our training in one way or another, so we're pretty proud of that. And so this idea of taking it on the road, right, this is when we were down in Austin a couple weeks ago, right, we do the normal PowerPoint, but then when we show up at your state, if you're a partner state, there's our trailer in the background, and we bring a bunch of specimens, and we'll demonstrate for this fatigue class, hole drilling and some basic non-destructive testing and whatnot in terms of retrofitting. And the students really like that, being able to walk up, have discussion, point at a fatigue crack, look at a retrofit. Here's a good one, here's a bad one, that kind of stuff. It seems to be quite attractive to individuals. But the retrofit class is the next one we're going to try to figure out how to get on the road. Again, it's getting all the drills and everything in the trailer. We might need to pick up an air compressor. But this was one NDOT recommended, and maybe some of you have had this issue where you've done a fatigue retrofit or some kind of retrofit on steel, and it turned out that now you're back in like 2 years because that retrofit didn't work, or unfortunately it was done poorly. NDOT had that on a bridge over the Ohio, and the retrofit required a retrofit that cost about $2.2 million because unfortunately they didn't quite do it right. So the idea was, how do we ensure that we're getting the hands-on part of retrofitting? Whether you're a program manager, so you understand what it takes, or a designer to understand what it takes, or a maintenance individual to know how to use a mag drill, right? And so that's what the class is for. So you get a specimen, right? As student, Stephen comes up, he will get his specimen, and we'll spend some time in the room talking about how to retrofit maybe hone bridge or constraint-induced fracture details. And we'll talk about what they should look like when they're done and so forth. But when you're done, you do your own specimen. So you get to practice, but then you're tested on doing that retrofit. So you're wearing coveralls and out there, and sparks are flying, and steel shards are ending up in people. And that's why I say it's the best class, or the worst class you'll ever love, because you're sweaty, you're dirty and everything, but everybody likes the class when it's all said and done. So that one's very attractive. And so those little girders that people get as specimens, that's what we'll be putting in the trailer and bringing to some of the partner states to get that. It's a small class. We have to limit it to about 6 or 8 just because of the tools and the personal attention it requires, but people really enjoy that class. And then the other side that our partners enjoy is the distributed expertise network. And at the end of the day, this is the pick up the phone, right, if you have a question about something. And, it's for partners, it's just it's included. It's not like there's a fee or anything like that. If it gets to be excessive, then we figure out how we can support you if we need additional money. But again, it's that expertise that just may not exist, or you want to bounce something off someone who you trust who doesn't have a dog in the race. Right? If somebody calls me about I'll show you a couple of retrofits, I don't have a financial interest in, whether you trash a new plate girder or you keep the new plate girder, right? Here's the approach to try to keep it going. And so the partners really value this as well. Some are quick. It's a phone call, a sketch or something like this. Some, I'll go out and look at a bridge, or I'll have somebody get involved. That's one of our partners who supports the SBRITE Center in the Den. We've done instrumentation for different states, right, as part of their fee. It's all just kind of included. So I'll give you a few examples, and then one of the big ones that we've been working on is the T1 steel, the Federal Highway Memo. Here's one that comes up all the time. Just on the phone this week with Michigan. Plug welds, right? And owners get concerned, as they should be, right? We don't want that lower right brittle fracture like we had on the Delaware River Bridge a few years ago. What do I do? Or, we've given guidance on hole drilling, but then they run into one, and this is what Michigan dealt with, okay, I got to drill these holes, but it's going to be really hard. I have conflict with other fasteners. Is there another way to do this? And so that's what we were working with them this week, is coming up with a retrofit on some cord members where they were really too close to other fasteners. They had some in a top flange tension region where they'd have to take off the deck to properly do it. Well, we don't want to get into doing that. What's a reasonable way and a reliable way to install that kind of retrofit, right? And so that way they feel good, they've got a retrofit, and then they can figure out how to implement it. And I'm not sure if they've taken the retrofit class yet, but they're then capable to go out and do it themselves with their own forces. So that's one that comes up all the time. Fabrication issues. I get a lot of calls on that, right? We're making the plate girder and we had this issue, or we have a non-destructive testing anomaly or reliability issue, right? How do I apply the fracture control plan? Or here's one typical. They didn't use the fracture control plan for this part of this member classified as an FCM. Is the sky going to fall, right? Well, here's what you can do to get around that. It's not that big of a deal, or yeah, maybe you should do something. And so here's one from South Dakota. I'm picking Michigan and South Dakota because I know they're not in the room, right? So they're not our southeastern partners. But they had one. They had a couple issues with some fabrication where it just, nobody's fault. Web to flange weld, a blow through. Oh, do we have to trash this, 80-foot piece of plate girder or so forth? So, hey, let's quick sketch something up. Here's something that can reliably keep the girder, right? It's not going to cost you $80,000 to build a new girder for no reason. Here's what we can do. I don't have a dog in the race, right? I'm not helping the fabricator by doing this. This is a reasonable retrofit. And if it was something worse, then maybe we would tell them, yeah, you're going to have to make them. I would encourage you to maybe get a new girder. In this case, they didn't have to do that. But that kind of support goes a long way. And then the big one is related to the Federal Highway Memo. Probably some of you are dealing with this. We've offered 2 webinars, I think, maybe it's 3. We partnered very closely with Federal Highway on this, and they actually broadcast one of ours nationwide about providing some guidance, Some big issues that have come up is how do you identify the butt welds and plates where they're equal thickness butt welds? And you might think, well, they're equal thickness. Well, if you remember on quenched and tempered plates, there were oven length limits, right? 40, 50 feet, which means if you have a 60-foot long quenched and tempered plate, there is a butt weld in there somewhere. Right? That's the only way you can make it longer, except they're equal thickness, so there's not going to be a reinforcement. They're going to be hard to find. How do you reliably do that without taking off paint? And so we did a little pilot study on that. There's issues with calibration and performance testing. Quenched and tempered steels have different acoustic properties than your traditional steels. And so a concern would be that you should be concerned about is if you're not calibrating on the same type of steel acoustically, you will either accept defects or reject defects that may or may not be an issue. As an example, if you calibrate on a steel that's acoustically more attenuating, maybe A36, maybe, and then you actually are inspecting a quenched and tempered steel that is less attenuating, a reflector will give you more sound back. And if you know D15, that's decibels. That means you'll get more sound from a reflector that if in the A36 plate was acceptable, would be rejectable now. Now you might think that's conservative until you have 600 butt welds and their reflectors are coming back, and now you have to figure out, do I need to repair those? Well, if you maybe calibrated more properly, they would all be acceptable, right? Because you would get the right amount of sound because you calibrated consistently. So that's a big one that we're working on. Glenn Washer and I over at Missouri, Glenn's leading that effort for us. And then this locating the CJP welds and the equal thickness components. And this, we issued a little white paper to our partner states. Federal Highway is a partner. And so if you did need that, if you have any questions about, well, how would you locate those kinds of welds, just reach out to your division engineer and he or she would be happy to provide that for you. And then we do have a special task kind of option that we can do because it's a pooled fund study. We've done these for a couple of states. For Minnesota. Minnesota's work led to, if you're familiar with the internal redundancy guide specifications, part of the work that's coming out in the latest ballot from AASHTO on trust members, that was because of that SBRITE subtask. Some subtasks on stiffener, oblique stiffeners, handholds, the fatigue provisions for handholds, that's SBRITE work, as well as the work we did with Wisconsin on twin tub girder redundancy. That was all SBRITE subtasks that are now getting into AASHTO, so nice impact. But this is going to be a fun one. This for South Dakota would be the lead subtask state. They have some two-girder bridges that are coming out of service, building a new bridge side by side. And the idea would be to conduct full-scale fracture simulations using shape charges to introduce a fracture into one of the two-girder bridges. So UT Austin did that nice work on the twin tubs, you may recall, where they cut the girder. We did some work on a truss. But although, those are very important tests, we don't have any data really on twin eye girders. Now, we know how to do the analysis. We all feel good about it. But there's nothing better than having a full-scale test to be able to then support, the finite element analysis to say, yes, Federal Highway, when we make that model, we have confidence it'll predict this. And so that's what this is going to be. And so some states have joined this portion only for that, right, like North Carolina. So there's our two-girder bridge down there. There's twin bridges side by side. We have states supporting this as well as some agencies. We're still looking for more partners. It's a rare opportunity, I can tell you. The stars have to align. You need a bridge coming out of service, a willing DOT, enough time to make this happen, right? Because there's risk associated with it, and everything seemed to line up pretty good. So we're hoping to do the fracture test in late 2023, depending on the construction schedule of the new bridge off to the left there, and hope to be up there this fall doing some instrumentation just to get our live load data and so forth. But, we're using some of our money. Our partners approved us to do some initial studies of the finite element analysis to get a feel of where would we fracture, what kind of load do we want on the bridge, if any, during the fracture, how do we want to actually perform this test. The big takeaway is then, as I mentioned, the twin tub girder provisions that are in the AASHTO guide specifications came out of SBRITE work. Our hope would be to have simplified methods, just like that are going to show up in the new interims, in the new guide spec appendix, would be to have simplified ways to either design new and hopefully evaluate maybe some existing two-eye girder bridges to do that system analysis without doing all the painful nonlinear finite element analysis. In other words, if I do this, I use this kind of detailing for shear studs, I have a floor beam connection that looks like this, I can say that the structure would meet the system redundancy. In other words, they're SRMs instead of FCM, and STMs, right? So that's kind of exciting. And so some general things through the Distributed Expertise Network, just a laundry list of different things we get involved with helping people with, from coatings to non-destructive testing to just good old fatigue and fracture retrofits. So I think it's a neat facility. It's been up and running for a number of years now. We've had great support with our partners. They've been our biggest advocates of other states joining, as them telling other states that it's a worthwhile investment. And I appreciate the opportunity to just come down and just let people know. Some people don't know it exists. And if you have any questions, I'd be happy to try to answer them. Go check out our website. There's free manuals about fatigue retrofitting and different things here and there. Some portions are a little outdated. We've got to update some things on it, but the documentation under the research is all nice stuff to be able to get hold of.
All right, if this is an infomercial, I'm the satisfied customer being interviewed at the end. For the DOTs out there, do yourselves a favor. Find an excuse to get up there and tour SBRITE. It is absolutely the best 50 grand we spend a year. The bang for your buck on this thing is really remarkable. It's an amazing training opportunity. Getting up there and seeing this stuff is really amazing. And Rob showed what he had done in our facility twice recently, so he takes it on the road. So please do yourself a favor and consider joining this pooled fund. It's a remarkable program.
Well, I wish I wrote that down for you to say. But that's the kind of stuff I appreciate that. Oh, incident, we're looking at some training November 9 and 10 on site. If you are a DOT and you'd like to send one person, give me a call if you want to get that experience of what it involves, because we might be able to squeeze somebody in. We wouldn't, you'd probably have to cover your travel, but we could at least maybe waive the fee for a DOT person who's not a partner.
So that was recorded? So you
I hopefully you're recording this. Yeah, I'll have to.
All right, let's give Rob one more hand. Time for a break.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.